Assalamu alaikum wa rahmatullahi wa barakatuh. Today, inshallah, we're going to work on differentiation of trigonometric functions. Let's start first of all on the rules of differentiation of trigonometric functions, because these are the basics that we need them in solving any question related to differentiation of trigonometric functions. First rule that we have is d by dx of sine x is equal to cosine x, and d by dx of cosine x is negative sine x. Inshallah subhanahu wa ta'ala, in the next topic we're going to talk about the other four ratios, which is tan, cot, cosec and sec. So today inshallah we're going to work only in these two ratios, these two functions, sine and cosine. So derivative of sine is cosine and derivative of cosine is negative sine. So that means d by dx, the derivative of sine of any function, is derivative of the function multiplying the derivative of the sine, which is cosine of the same function, and d by dx of cosine of any function is derivative of the function multiplying by derivative of cosine, which is negative sine f of x. These are the rules that we need them. If we're going to talk about the derivative of any powered functions like sine power of n of f of x, so we're going to do that into three steps, as we do normally in the chain rule. You remember in the chain rule, we did the differentiation into three steps. The first step is to move the old power as a coefficient. Second step is to reduce the power by 1. And the last part is the derivative of the sine itself. So we're going to back to the spot. So derivative of sine f of x is f dash of x, and the differentiation of the sine is cosine f of x. So which means the final answer is n f dash of x sine n power of n minus 1 of the function multiplying cosine of the same function, because derivative of the sine is cosine. The other rule of the powered function, which is related to cosine. By the way, you can apply this rule for all the ratios. I mean for the tan, cot, sec, cosec and everything else. So we're going to apply the chain rule as we did in the first topic that we did in differentiation. So move the power as a coefficient, then reduce the power by 1. Differentiate of f of x is f dash of x, and derivative of cosine is negative sine f of x. So the final answer is negative n f dash of x cosine power of n minus 1 f of x sine f of x. Let's take a question. For example, d by dx sine of 4x minus 2. So you have to differentiate the 4x minus 2 first, which is 4, and derivative of the sine is cosine 4x minus 2. So only two parts in this type of differentiation. Cosine as well, so d by dx of quarter cosine of 2x plus 1. Derivative of 2x plus 1 is 2, so multiply that by quarter, which is outside, and then derivative of the cosine is negative sine of the same expression. Then the final answer is negative half sine of 2x plus 1. Good. Now let's try powered function, whatever sine or cosine. I'll do both. D by dx of 3 sine power of 2 of 3x. So we apply that. The rule will be into three parts, three different parts. Move the power and multiply by the coefficient. So 2 by 3 is 6. Then reduce the power by 1. And then multiply by derivative of the sine, which is cosine of 3x, and remember to multiply by derivative of 3x, which is 3. Good. Now I'll just remind you that we did in semester 1 in trigonometry. If you remember, we was having sine of the double angle. Sine of the double angle, sine of 2x is 2 sine x cosine x. We can apply this here. So we're going to split the 6 into 2 parts, 2 times 3. So we need 2 sine of 3x cosine of 3x multiplying 3 multiplying 3. So that 3 multiplying 2 will give you 6. Okay, then this part now is the sine of the double angle. 3 by 3 is 9. So 9 sine double of 3x, or 9 sine of 6x. Or directly from this step, without simplifying in terms of sine of the double angle, you just multiply 3 by 6, which is equal to 18 sine of 3x cosine of 3x, and that's it. Now exercise 5c from the textbook. This is page 130 and 131. We're going to do question number 3. Basically in this question it's required to find the equation of the tangent, but we're going to do both tangent and normal. So find equations of tangent and normal to the curve y equals 2 sine of 6x at pi over 6 and 0. Alhamdulillah, they give us x and y. Now we're supposed to differentiate and do the normal step that we did normally in finding equations of tangent and normal. So the first step ever in finding equation of tangent and normal is to differentiate the function. Before that, you have to check x and y are given to you both. So directly you have to start to differentiate the function. So y dash is derivative of the 6x, which is 6. So remember to write 2 multiplying by 6, and then derivative of sine is cosine of 6x. 2 by 6 is 12 cosine of 6x. Now second step is to find gradient of the tangent. You know that by replacing x value in the derivative, we can find the gradient of the tangent. So it's 12 cosine 6 by pi over 6. You remember that pi over 6 in radian in degrees is equal to 30 degrees. So 6 multiplying 6 and the 6 multiplying 1 over 6, they will cancel each other. You have cosine pi. Cosine pi is what cosine 180. By using the calculator, the gradient is negative 12. Then gradient of the normal is positive 12. This part for the tangent and this part for the normal. Y minus 0, because the y coordinate is 0. Here is it. And the gradient is negative 12x minus pi over 6. Pi over 6. Same thing for the normal. Y minus 0 equals the gradient of the normal. Gradient of the normal is 1 over 12. You have to flip and change the sign of the gradient of the tangent. So it's 1 over 12 x minus pi over 6. Expand the brackets. Y minus 0 is y. Negative 12 x minus, negative by negative is positive. 12 by pi over 6 is 2 pi. This is the equation of the tangent. Then the equation of the normal, y minus 0 is y, 1 over 12 x minus pi over 36. And that's it. This is the equation of the normal. Okay, we're going to do now question number 4. Find the x coordinates. Yes, x coordinates of the stationary points on the curve y equals x plus sine 2x for the range of the x values from 0 to pi. Again, the first step is to differentiate the given function. So y dash, derivative of the x is 1, derivative of 2 x is 2 and sine is cosine 2x. Remember, in the stationary point, y dash equals to 0. You just move 1 to the other side and divide both sides by 2. So cosine of 2x is negative half. If you remember that we did in semester 1 in trigonometry, we're supposed to change the range which is given to you because you have double of the angle. So the new range is from 0 to 2 pi, which means we have to walk in 4 quadrants. Quadrant 1, 2, 3, 4. 0, pi, pi, this is pi over 2, 3 pi over 2, and 2 pi. Now we're going to reach to one more thing, but after you finish this question, all questions on differentiation of trigonometric functions, all the angles, you have to work it in radian, not in degrees. All the questions that we're going to do in differentiation of trigonometric functions, we're supposed to work only in one type of angles, which is radian. So from the beginning, before you start to work in differentiation or mathematics in this semester, in the whole of this semester, you have to change the calculator mode to radian, because we never work at all in degrees, because this is the only part that we have it related to the angles. So you have to change the calculator mode into radian. Okay, now cosine negative, you remember that ASTC, so cosine positive in these 2 quadrants and negative in these 2 quadrants. So we're supposed to find the answers in these 2 quadrants. The range on the first quadrant is pi plus theta, and on the third quadrant is pi minus theta. So second pi minus theta, pi plus theta, and on the second is pi minus theta. So just we flip them. Pi minus theta and pi plus theta. First quadrant is pi minus theta. Third quadrant is pi plus theta. Fine. Fine. Now we're going to find the angle. So 2x is equal to inverse cosine of half. Remember, you have to work only in positive. Inverse cosine of half is equal to pi over 3, which is 60. Then 2x equals to pi minus pi over 3 and pi plus pi over 3. By dividing both sides by 2, then x is equal to, this is 2 pi over 3, by dividing by 2, you will get pi over 3, and this is 4 pi over 3 dividing 2 is 2 pi over 3. These are the x coordinates. And of course, if you want to find the y coordinates, you just replace the x on the main functions. But the question asks you only for the x coordinates. So if you want to find y, you just do pi over 3 plus sine 2 pi over 3, and y equals to 2 pi over 3 sine plus sine of 2 multiplying 2 pi over 3. Then you can find the y easily. Here we go. Another question, in question number 5, it's required to find the first derivative of sine pi x degrees. So this is degrees, and I told you we have to change all the types of the angles that you're going to work with in differentiation of trigonometry in radian. Changing from degrees to radian is to multiply the angle by pi over 180. So before you start to differentiate, you just keep the derivative and you change the angle first. So sine pi x times pi over 180. Then d by dx sine pi times pi is pi squared. This is times, and this is x. So sine of pi squared over 180x. Rule of differentiation of sine is derivative of what you have in sine. So remember, this is a number, coefficient, constant. Derivative of any constant multiplying x is the constant itself. So you're supposed to write pi squared over 180. Then derivative of the sine is cosine of pi squared over 180x, or pi squared over 180 cosine of pi over 6 or pi x degrees. So you can write it in both ways. Then question number 6. Question number 6, it's required to prove that show that y equals to sine x plus cosine x all squared. Show that d2y, the second derivative, plus 4 sine 2x equals to 0. First of all, before you start in proving the identity, we have to simplify the given function. So this is a perfect square expression, which is a plus b squared equals to a squared plus 2ab plus b squared. So the function is sine squared x plus 2 sine x cosine x plus cosine squared x. Sine squared plus cosine squared is equal to 1. 2 sine cosine is sine of the double angle, so sine of 2x. Now let's differentiate. The derivative of the 1 is cancelled because it's 0. Derivative of the sine 2x is 2 cosine 2x. Then derivative, the second derivative, differentiating one more time. Derivative of the 2x is 2 multiplying by 2, which is outside, is 4. And the derivative of the cosine is negative sine of 2x. This is the second derivative. Now let's back to the identity. The left hand side, second derivative that we got is negative 4 sine 2x. And then you have already 4 sine 2x. These two terms are like terms and they're having different signs. The sum of them is what? 0. Then it's equals to right hand side. Proved. Here we go again. Question number 7, it's required to find the first derivative, differentiate with respect to x. So derivative of 4 sine squared of 2x. So we're going to use the chain rule. Remember, first step is to multiply by the coefficients. So move the power and multiply by the 4, which is 8. Then reduce the power by 1. Then multiply by derivative of the sine 2x. Derivative of the sine 2x is 2 cosine 2x. Good. Now sine 2x, 2 cosine 2x are representing the sine of the double angle. So you can write 8 sine double of 2x, which is equal to 8 sine of 4x. Or if you want to write it in a simplest form without expressing them in a sine of the double angle, you just multiply 2 by the 8, then you will get 16 sine 2x cosine 2x. Okay, let's do question number 8, which is required to do the same thing as we did in question number 7. Remember, here you have e. So we can solve this question using two ways. The first way, we're going to use the second way of chain rule, which is replacing the power as any other variable. Let's do the same thing. So we're going to call y equals 4 e power of u, and u is equal to cosine squared x. Now you remember y, you differentiate y respecting to u, and you differentiate u respecting to x. So then at the end you're going to multiply them. Remember, this is the second way of the chain rule. So derivative of this will be 4 e power of u, because derivative of e never change. And du by dx is move the power, so 2 cosine power of 1, and derivative of the cosine is negative sine x. 2 cosine sine is double angle, sine of the double angle, so negative sine of 2x. Then dy by dx is dy by du times du by dx. dy by du is 4e power of u, and du by dx is sine of 2x. If you want to write the answer in the simplest form in terms of only x, you just replace u to be in terms of x. So you write 4e power of cosine squared x sine of 2x, or 4 sine 2x cosine, or e power of cosine squared x. The second way that we can solve this question is using normal way. See, another way, d by dx of 4 e power of cosine squared x. What you're supposed to do, derivative of e is derivative of the power times 4 itself. So you keep the 4 as it is without any change. Then derivative of the cosine squared is 2 cosine x multiplying by negative sine x, and keep e power of cosine squared x as it is. This part is sine of the double angle, but remember you have a negative sign, so negative 4 sine of 2x e power of cosine squared x. So you get exactly the same thing. Let's do this question, which is in the same part, d by dx of ln sine of 2x. You remember that derivative of the ln is derivative of what you have inside over the function itself. So it's f of f dash of x over f of x. Keep the sine 2x as it is in the denominator and differentiate sine 2x itself. Derivative of the 2x is 2 and sine is cosine 2x. Cosine divided sine is the reciprocal of tan, which is cot. So it's 2 cot of 2x. Then let's do question number 9. Find dy by dx in terms of y. You remember we did the same question before in the chain rule, in the first topic in differentiation, in terms of y. So basically in the question they gave you the, let's do b, they give you x in terms of y. X is equal to quarter cosine of 2y minus 1. What you're supposed to do, you have to differentiate the function first, respecting to y. And then at the end, you're going to find the reciprocal. So keep the quarter as it is. Derivative of the 2y minus 1 is 2, and cosine is negative sine of the same expression. Negative quarter times 2 is equal to negative half sine of 2y minus 1. Now this is the dx by dy. If you want to find dy by dx, you just flip that. So it's 1 over dx by dy, which is 1 dividing negative half sine of 2y minus 1. 1 divided negative half is equal to negative 2, and the reciprocal of sine is cosec of 2y minus 1. Thank you.